And I think we'll kick it off with Ed Wodarski. So he's going to give us a look back to the historical perspective of service parts management. And he's going to leverage his 4-decade career where he'll take a look back at where everything started, some of the implications of the evolution of service, and the implications that has on service parts planning. Then he'll also talk about some of the emerging technologies within the space that are really influencing service parts management, service business itself, like artificial intelligence, machine learning, big data, and IoT. So Ed, thank you for taking time to share your experience with us today. We'll turn it over to you.
Thanks, Bradley. Good morning, good afternoon to everyone. So as Bradley said, I'm going to take us in the Wayback Machine for a few minutes here. And while the topic today is going to be about state of the art for service parts planning, I'm going to give us some background on how we got there. And it's an interesting journey. The term supply chain is attributed to a British newspaper, The Independent, in 1905. But the term service or supply chain management itself doesn't come into the lexicon until the 1980s. So what we're talking about is relatively new concepts. When I started, there was no such thing as a supply chain industry. There were no supply chain professionals. There were no degrees in supply chain. What we had was MRP, and an MRP, materials requirement planning, was really the only supply chain tool in existence, and it was specifically and very, very specifically dedicated to manufacturing planning. And essentially, it was a glorified bill of material explosion program that exploded a bomb and offset the component lead times and created a supply plan to ensure that the parts were there. MRP doesn't get interesting until companies like I2 in the late 1980s, early 1990s started incorporating production constraints into the model, which much more accurately represented the challenge of getting product through a factory by looking at scheduling and load leveling. But specifically to service planning, MRP's limitations are many. Manufacturing knows what's in the BOM. They know what the demand is going to be. It's called deterministic demand. It's fairly simple arithmetic. If you're going to make 100 of these and you need 2 in each one, you need 200 parts. And they needed every one of them to assemble the product. So it really wasn't a particularly great challenge. Their philosophy was just in time. I want to get inventory in to my network to minimize the amount of time I own it and have to pay to warehouse it. On the other hand, service deals with what we call stochastic or probabilistic demand. And because of that, we have a just-in-case philosophy. We have to carry inventory in case something fails because we don't have a production schedule that we're marching to. And because no one could be profitable by carrying every part at every location that might demand it, we have a very, very different approach to planning. Manufacturing and MRP also only dealt with the current bill of materials and the current component revisions. Obviously, we have to deal with legacy products and the inherent interchangeability issues that comes with that. MRP used new parts. Many of our verticals lifeline is reverse logistics and repair pipeline, which MRP didn't comprehend. And if any of you have tried to implement service parts planning and ERP systems, you may have found some of the difficulties in dealing with repairable parts because inherently their MRP, which is the baseline for their planning solutions, really doesn't understand that concept. And then MRP dealt with a location. It dealt with a plant. Service, we have to deal with a network. And that network is dynamic. It's vibrant. Material moves around. We have material flows of replenishment and rebalancing and returns and excess recalls, none of which were comprehended within MRP. And so the story about service parts planning then really starts with Xerox in the late 1970s. The Japanese introduced low volume copiers, which Xerox didn't see coming. They had dismissed that market as not particularly viable, and they completely read it wrong. Demand turned out to be much greater than anyone had expected. And as a result, Xerox rushed product to market. They rushed the engineering cycle and the testing cycles. And because they wanted to stem the tide, they flooded their sales channels in every one of their geographies with this really not ready for prime time product. And very quickly, they realized they had a massive service problem and on a global scale. The low volume copier launch was a disaster. The products had many, many points of failure. And so what they ended up with was engineering, redesigning products in real time. And parts were being issued weekly, sometimes daily. So part chains were dynamic. They were changing all the time, which created huge problems for the field who didn't know which part they were supposed to be using. It's very difficult in those times to communicate to 5,000 service engineers around the world that -2 has now replaced a -1, or a procedure for repairing a product has changed. And so it was a complete mess. And compounding that, the transaction systems weren't used to dealing with the revisions either. And so they couldn't identify which parts were being demanded. So they just knew a fuser roll had been demanded. But because of all the engineering changes, that could be one of 5 or 6 different parts. And so it was chaos. And unfortunately, MRP was what they would have called state of the art. So it was at this point Xerox said, we have to fix this. And they assembled a team with practitioners from their global supply chain practices and academics, including Jack Muckstadt, who had a very long-standing relationship with the evolution of service parts management out of Cornell University. Researchers and other interested parties, and they developed a set of requirements to become the first custom developed solution for service parts planning. So I finished graduate school in '81 and started at Xerox and was put on this team. So service parts planning was born in 1981. I started then. So those of you who are good at math, this is my 40th year of working with this technology. And originally, I was put on the team to validate the math that they developed, and once things were coded, to evaluate the results. And it was a profound change. It had great impact on Xerox and gave them much more control over the service problem. And the reason I take us through this story is because this original system called MPS, Material Planning System, very creative. It is foundational. In that it not only was the first application to challenge specifically the service supply chain problem, but it also became the blueprint for the first commercial application, because at LPA, we started with the requirements of the Xerox solution and grew things from there. So it really was the genesis of this industry we talk about today. But if we were to look at MPS, we would not consider it to be a particularly viable solution for state-of-the-art service parts planning, because so many things have changed in those ensuing 40 years. And so for the few minutes I have left, I'm going to try to bring us to the current state in terms of what we think is important and happening in the space of parts planning. So I'm going to talk about 3 themes. The first one is the focus of service shifts to the service customer. And this sounds intuitively obvious, but it really isn't. When I started, the focus was finance. We were given a budget, we worked within the budget, and there was no correlation between that budget and its impact on the ability to deliver service. And very often we see in organizations where the customer for the parts planning, which is a maintenance organization or a field service organization, actually have metrics that pit them against one another, where because the service delivery person wants to have every part everywhere so that they never have to disrupt their operation, and the materials people want to have as little inventory as possible because they're measured on the value of their inventory. So right from the get-go, we have not focused on the customer in terms of our goals. The second is the role service plays in an enterprise, and this is interesting too, and it's fairly recent, because for a long time service was considered a cost center. With Xerox, it was a cost of doing business. You didn't do it to generate revenue or to create brand loyalty or repeat purchases. You did it because you had to. If the copier didn't work, the customer was going to complain. But everything was done in a break fix environment. But now people have realized the true role service plays in terms of its ability to generate revenue, and very profitable revenue, often more profitable than the revenue of the sale of the product itself. And so service now has a seat at the table that a decade or so ago it didn't have. And the third theme is about the availability of new advanced data science, and how, coupled with the ability to interact with the assets directly through an IoT environment, really create opportunities to transform how we plan parts today. Candidly, there's only so many features you can add to a system, and with an application that's as mature as ours, we've kind of hit that wall. What we needed to do was take a look at opportunities to innovate and change how people plan parts, not just adding another variable to a forecasting algorithm. And we'll talk about that in a minute. So what does it mean that we've shifted the focus to the customer? Well, we can see it in what their expectations are. While there's still a number of people who prefer a break fix environment where they have a relationship with their service provider, where they just call an 800 number when their product fails, more and more people have increased their expectations with their vendor to have some skin in the game, some shared risk. And what that's done is spawned whole new business models around service level agreements, or in the defense world, there's different terminology for that. But the point here is we now have contractually binding relationships between the service provider and the customer, where there's some metric that represents the goals of the customer, whether it's uptime, availability, or response time, or recovery time. The service provider now has a very, very clear cut and contractually binding set of goals. And that's very different than the environment that I started out in, where you did as little as you could, you spent as little as you could, and you only changed things when the customer noise got louder. But these emergence of new business models are really, really transforming how service organizations interact with their customers. The implications of service becoming a revenue generator rather than a cost center is that it's got a much more strategic role in an organization now. Where 20 years ago, we were never talked about in SI and OP planning, because nobody really worried about the revenue. They just cared about some inventory number. And that's dramatically changed, where we're a critical part of revenue generation. And therefore, we have some relationships in an enterprise that we might not have otherwise had before. And we have different stakeholders now. We have people in sales and marketing organizations that are driven to sell more service, and recognize that service can be a market differentiator. Very often there are products that have fairly similar product feature sets, and it's reliability and maintainability that differentiate one from another and create brand loyalty and brand equity and repeat business. So service really does have a much more strategic role in the enterprise now than it ever had before. And now we have new technology. We've had the emergence of advanced data science for quite a while now. Things like artificial intelligence and machine learning have been around for a number of years, but we now have computing power and data storage costs that are low enough that they're practically applicable. They're not science projects anymore. They're actually things that we can use to solve real world problems. And for service parts planning, the Internet of Things gives us a whole different source of information. We like to break reliance on demand history and forecasting and use things like causal factors. But for many verticals, causal factors are in and of themselves forecasts. So if I'm looking at projecting what the install base would look like in the future, or what its activity profiles might be, well, connecting directly to the assets replaces that proxy data with real live data. We get to see how many assets we're supporting. We get to see what their operational hours are, what their activity profiles are, and we know where they are, which helps in deploying the inventory. And then what machine learning and artificial intelligence allow us to do is develop analytics sets that sit atop the traditional service parts planning world, which by definition kind of focuses part by part, and look at macro level things to look for systemic issues that the planning system might be able to address. And so I'm going to take a couple minutes here and then talk about what the implications of these three themes are for parts planning itself. And the first one related to focusing on the customer, it's very interesting. We measure the wrong thing very often. It's nearly impossible to try to correlate something like inventory turns with customer satisfaction. I mean, inventory turns was developed for consumer packaged goods to look at how many times the Coke emptied off the end cap at the grocery store. It doesn't lend itself very well to parts that are used 12 times a year across a 100 location network. And you can manipulate the data. You can load up on low volume or high volume inexpensive parts and drive up your inventory turns. But that's just to measure how many parts you have. It doesn't measure whether you have the right ones at all. In fact, you can manipulate it by buying the wrong ones. Fill rate has some of the same issues. It doesn't necessarily correlate to customer satisfaction. If you take your car to the service center and they tell you the good news is I have 9 out of the 10 parts. I got a 90% fill rate out of my parts window, but unfortunately I'm not going to have that 10th part for a week. You're without a car for a week. You're not happy. You don't care about that fill rate. You care that they fix your car within the window of time that you would expect it. And you can also manipulate fill rate data with the same things you could have with inventory turns by stocking high volume, inexpensive parts. The problem is the expensive, low volume parts tend to be the critical ones that keep equipment from being turned back in an operational state. And if you're not carrying them, you can have the greatest fill rate in the world. You're not going to have a happy customer. And as I already mentioned, we're now seeing new business models specifically because of that, because the metrics we have had didn't really correlate to whether the customer is being satisfied. So they've decided they're going to drive the metrics, and those metrics are being embedded in service level agreement contracts. And people are becoming ever more clever in terms of the different types of service offerings they have. Obviously, we have gradations like silver, platinum, gold type service. But what does that mean? What are the metrics? Am I focusing on availability of the equipment or response time by the service engineer or how long it took it to get back up? But the point is, all of the metrics now and all those goals focus specifically on the planner. It was a very strange world for decades in material planning. And the reason I say that is budgets were established for how much inventory service could carry. And they were largely done by a finance community without any discussion with the customer, who is really the maintenance or field service organization, or the material planning people. And so the service parts planning guy got assigned a number, and he was monkey in the middle. There was no discussion that said, here's an exchange curve mapping level of service and availability. You put me on this dollar value that translates to this level of service. Mr. VP of field service, are you happy with that? Those discussions didn't happen. There was no forum to have a facts-based discussion. And in many ways, finance was considered the customer of the material planning organization, which is even further removed from the end customer themselves. And so now what we see is the opportunity to create optimization engines that create the roster of parts that meet those availability goals with the least amount of inventory. And we can constrain them with budgets if there's economic stress that needs to be represented. But the point is, the models are driven based on the current metrics as defined in service level agreements, as opposed to some of the inward-looking metrics that really didn't represent the customer. And service level agreements have a life cycle. We need to recognize that there's a whole host of analysis that happens up front in determining what I'm going to offer. What does a platinum level of service mean, and how is that different than a gold one? Is it a 2-hour, 4-hour, 12-hour response time? And so now we have stakeholders using the output of service parts planning optimization to evaluate alternative service offerings based on their cost and therefore their profitability. And so the last part of this here is the Internet of Things and advanced data science. And history is a horrible indicator of the future for field service. There are too many cycles at play. There's economic cycles and calendar cycles and product life cycles, all of which really need to be comprehended, but history frustrates. And so we want to break that reliance on history. It's easy to understand why using demand history sustained for so many years. It's easy to understand, easy to compute, doesn't need a lot of data or computing horsepower, but it assumes yesterday looks like tomorrow. And all we have to do is look at COVID and the impact it's had on many of our organizations who had either demand spikes or demands fall off the end of a cliff. And demand history now would have them planning a totally inappropriate environment. So we needed something that was much more adaptable. And so we've had things like causal forecasting for years, but now introducing the IoT environment, we would now be able to see that equipment is being turned off, service level contracts were not being renewed, and break that into the model. And the other half of this equation is things like machine learning and artificial intelligence. And much of the analysis, as I said, happens at the part location level, and it has to, because that's where the rubber meets the road. But there are opportunities to take a step back and look more holistically at the entire planning environment and look for systemic issues. And that's where machine learning and artificial intelligence come into play. And we've represented them in our performance analytics and intelligence module, where we can take things like forecast accuracy, for example, and try to identify parts that may be suffering from the same issue, but are not in any way related to each other. For example, we may be systemically biasing a forecast high for this group of parts. We may not know what links those parts, but artificial intelligence and machine learning have found that they have a similar pattern. And we can then have the system tell us how to change the tuning of the engine to be able to better forecast those parts. So the future here is the opportunity to have the introduction of semi-autonomous planning, where while the system for a long time has been making recommendations at a part level for how to take actions, we're now making recommendations at an enterprise level to tune the model better itself. And that creates a very, very different future for service parts planning and the role within it. So Bradley, I'll turn it back to you.